Okay, so water is a very important component of every human being. Okay, and we should be able to understand the the composition of water and then the various compartments of the human being where this um, water is what is compartmentalized. Okay, I'm sure we all know this already, so it's going to be a revision. Okay, so when we take any human being, okay, we say the average weight of a human being is about 70 kilograms. When we take this average human being, okay, about 60% of the person's weight is water. Okay, so if the person weighs, let's say, 70 kilograms, we are saying that 60% of this person's weight is water. Okay, so if we do the maths, we realize that we will get 42 kilograms. So 42 kilograms of the person's weight is just water. Okay, and because the density of water is one kilogram per liter. Okay, we can say 1 liter is equivalent to 1 kilogram. Therefore, we can say the total body water of a 70 kilogram man is 42 liters. That's the first important point. Now, okay, so now what's going to happen now is that I'll be using two terms and they are not the same. I'll be using total body weight and total body water. The two terms are not the same. Okay, so you should be able to understand when I use total body weight or total body water. Okay, so I'm saying number one that 60% of the person's total weight is water. So therefore, the total body water is equal to 60% of the total body weight. That's the first principle. The second principle is that when we take this total body water, okay, we can divide it into two. We have those that are in the intracellular compartments, that is inside the cells, and then the extracellular compartment, which is outside the cells. Okay. So when we take this 60%, which is water, 40 out of this 60, okay, I can break down the 60 into 40 and 20. Okay, 40 per okay, let me be very clear. 40 out of this 60 is found in the intracellular compartment, and then 20, okay, the remaining 20 is found in the extracellular compartment. So in a way, okay, this part is very confusing. That's why I'm taking my time. In a way, we can say that 40% of the total body weight, okay, is water, which is found in the intracellular compartment. Okay, and then 20% of the total body weight is water, which is found in the extracellular compartment. Okay, another way of saying this is that 2 out of 3, okay, or 2/3 of the total body water is found in the intracellular compartment. Okay, which is about 66%. So I can say that 66.6% of the total body water is found in the intracellular compartment, or 40% of the total body weight is found in the intracellular compartment. So it depends on which term I'm using. If I'm using total body weight, then the intracellular compartment will be 40%. But if I'm using total body water, okay, then the intracellular compartment will be 2/3 of the total body water. Please, is this point clear? I need response before I continue. Is this point clear?
Yeah, Brian.
Yes.
Please take it again.
Please, can you go back?
Okay, let me go
Okay,
back.
again.
So I'm saying that there are two terminologies over here. Total body water, okay, and then total body weight. Now, the first equation is this. The first equation is that 60% of the person's weight, okay, 60% of the person's weight is water. Okay, so the total body water is 60% of the person's weight. So that means that if the person weighs 70 kilograms, if I find 60% of it, that will give me 42 kilograms, which is equivalent to 42 liters of total body water. That's the first point. So total body water is equal to total body water is equal to 60%
Is that what the whole thing
of
is
total
about?
body weight. Okay, good. Now
Okay.
the second equation is that when I take the total body weight, when I take the total body water, two and then 2/3 of the total body water is found in the intracellular compartment. So 2/3 of the total body water. I'm using the term total body. So when I take the 42
But
liters, 2/3 of the 42 liters is found in the intracellular compartment. Okay, so if we do the maths, okay, if we do the maths, we'll get to. I'm coming. So let me try and write it over here. So we have total body water. Okay, this is total body water. Okay, um, wait, let me try and make it clear.
will Apostle come back?
Wait, give me a minute. Oh, God. Hmm. Okay, so okay, so I'm going to use this to explain. Okay, there is something here. Oh, okay, good. So this is what I was trying to say. Good. So I was saying that the total body water okay, the total body water is divided into two parts. Okay, we have the intracellular compartments and the extracellular compartments. Okay, so yeah, someone's hand is up. Please, can you see the slide?
Yes,
Uh-huh.
we can.
Good. So I'm saying that you see the total body water, okay, the the total body water is 60% of the total body weight. Okay, so total body water, okay, so 60% of the total body weight is equal to total body water. Okay, now out of this, okay, we are saying that two-thirds of the total body water, two-thirds of the total body water is in the intracellular compartment. And we know that the total body water is 60%. Okay, so if I find 60%, if I find two-thirds of this, okay, I'll get 40%. So there are two ways of saying it. Okay, I can say that the intracellular compartment, okay, is equal to two-thirds of total body water, or intracellular compartment is equal to 40% of total body weight. So I can use either total body weight or total body water. Okay, and if I'm using total body water, okay, then the intracellular compartment is two-thirds of the total body water. Okay, or if I'm using the total body weight, then the intracellular compartment is 40% of the total body weight. Okay, and the whole idea is this: if I take 60%, if I take this 60%, we are saying 60% of the total body weight is equal to water. Okay, if I take 60% of this, two-thirds of 60% is 40%. So I can divide that 60% into three. Okay, then two out of this three will be in the intracellular compartment, then one out of the three will be in the extracellular compartment. Okay, so I'm stressing this so that you understand that we can say that two-thirds of the total body water is in the intracellular compartments, which is equivalent to 40% of the total body weight. Please, is this point clear? I don't know how to make it clear again. Please, is this point clear?
Yes, please. Yes, please.
Okay, so we can move on. Good. So now let me go over it again. When you take an average 70 kilogram man, 60% of the person's weight is total body water. When I take this total body water, two-thirds of this total body water is found in the intracellular compartment, one-third is found in the extracellular compartment. Okay. Now when I take 42 liters, okay, 42 liters is the total body water. If I find two-thirds of it, okay, if I find two-thirds of it, that will give me 28 liters. So that means that 28 liters, which is 2 out of 3 times 42, okay, that's 28 liters. That will be found in the intracellular compartment. Then we have one out of 3, okay, one-third of the total body water, which is found in the intracellular compartment. So one out of 3 times 42 give us 14 liters. So that means that 14 liters of water is found in the extracellular compartment. Okay. Now, when you take this extracellular compartment, we can further break the extracellular compartment into three different chambers, okay, or three different compartments. One, we have the interstitium. So the interstitium is just the space surrounding the cells, okay, and then we have the plasma. Okay, we have plasma. We have plasma. The plasma is the fluid part of blood. Now listen very carefully. The plasma is the fluid part of blood. So that means that when I take the cells of blood, okay, when I take something like red blood cells white blood cells. The fluids inside the red blood cells is part of intracellular compartment. It's not part of the plasma. Okay, let this be very clear. When you take the red blood cells, white blood cells, though they form part of blood, okay, but the fluid inside them are inside the red blood cells are considered part of the intracellular compartment. So that means that the extracellular compartment is only the plasma part of blood. Okay, good. Someone's hand is up. Do you have a question? Okay, let's continue. So we have the plasma and we have the interstitium. Okay, so there's a third space for the clinical student. Okay, just for the clinical student, that space is called the transcellular space. Okay, transcellular space, or the third space. Okay, or transcellular space. Now when you talk about this transcellular space, that includes fluid which is found in the joints, fluid which is found in the pleural. Okay, the pleural space, the fluid over there, the peritoneal fluid, as well as the CSF. Okay, these kind of fluids form what is called the transcellular fluid. Okay, but I mean, you can forget about that and just concentrate on the interstitium and plasma. Okay, so the interstitium is 10.5, the plasma is 3.5
Right.
liters. Yes.
Yeah, please, for the plasma, can you go over again? Where the
Yeah.
plasma is found.
Yeah. So I'm saying that the plasma is the blood consists of cells and plasma. Okay, the plasma is the fluid part, or the liquid part of the liquid part of the or the fluid part of the blood. Okay, and that one is 3.5 liters. Okay, so that means that when I take the cellular compartment or the cellular components of blood, like white blood cells, um, red blood cells, okay, the fluid inside these cells are also part of the intracellular compartments. So you notice that though we say someone has, let's say, 5 liters of blood, okay, you notice that the plasma is only 3.5 liters. The remaining 1.5 liters is from the cells. Okay, is from the white blood cells, and then the red blood cells. They make up the remaining 1.5 liters. But the plasma alone is 3.5 liters. Okay, so don't be confused. I'm saying this because someone will say, oh, but I thought we have 5 liters of blood. But why are they saying that the plasma is only 3.5? Yes, the plasma is only 3.5. The remaining 1.5 is for the the fluid in the cells, the red blood cells and the white blood cells. Good. So now the next question is that how were they able to measure these volumes? How were they able to know that intracellular compartment is 2/3 of the total body water, and the extracellular compartment is 1/3 of the total body water? So what they did was to inject.
No, right, sorry.
Yes.
So from what you are saying, then I'm deducing that the plasma is intracellular, because from what you are saying, you are like the plasma is the one inside the cell.
No.
Unless I'm wrong.
Yes. I'm not saying that. I'm saying that the you see when you take blood has plasma, okay, and then blood has cells. So the plasma is the non-cellular part, okay. But when we take the cells themselves, like the red blood cells, white blood cells, okay, the fluid inside the red blood cells are part of the intracellular compartment. But the plasma, you see, the plasma is not the red blood cell. The plasma is different from the red blood cell or the white blood cell, okay. So the plasma is just water, electrolytes, hormones, and other stuff. Okay, so those ones are different from the cells. Okay, so don't confuse it. Please, is it clear?
Yeah, thank you.
Okay, someone's hand is up. Do you have a question? Okay, let's continue. So now how were they able to measure this? So what they did was to use the concept of volume distribution, okay, which you guys learned in pharmacology. Okay, volume distribution. Now, what they are going to do is that they are going to inject this. They are going to inject certain dyes, okay, in the person, okay. Now, some of the dye only remain in plasma, okay. Other dyes, okay, can be in the plasma and be in the interstitium, okay. And then some of the dyes too can move. You see, we inject it into the person's plasma. So if the dye only stays in the plasma, okay, then we can use that principle to find the plasma volume. If it moves from the plasma into the interstitium, then we can use that to find the extracellular compartment, okay. But there are some of the dyes that can move into the the intracellular compartments, okay. So what you must know is that which dyes can be in the plasma, okay. Which of them can be both in the plasma and the interstitium, and then which of them can be both in the plasma, in the interstitium, and then in the in intracellular compartment, okay. So what they did was to inject these dyes, and then after they inject the dye, they will allow for some time, okay. Then they will take the blood sample and then find the concentration of the dye, okay. Then they will use the formula concentration is equal to mass over volume, okay. Yes, the mass concentration is equal to mass over volume. Then they will make volume the subjects, and then they will get the volume of distribution, okay. So there are properties of the dyes that you could use, okay. One, the dye should be easily measurable in the laboratory, okay. And it should have uniform volume of distribution, and it should be confined within the volume. So if you are measuring plasma volume, that dye must stay within the plasma, okay. And then ideally it should not be metabolized or excreted. But later on we will know that some of them can be excreted by the kidney. So we will see how to go about all those ones, okay. Good. uh, Anyone with any questions? Okay, let's continue. So let me see. I've talked about all these things. Okay, so let's look at this slide. So one one the the dye that can go, okay, into all the spaces, okay. So for those dyes, we can use them to calculate the total body water, okay. And obviously, because how do you call it, because water can move everywhere, okay. Just remember that yeah, someone is asking if it cannot be excreted, how do you get it out of your system? So that's why we said ideal. That's why we said that should be an ideal dye, okay. But we don't have such an ideal dye, so eventually you can excrete it, okay. So that's why we're saying ideally, okay. But um and then even note that we are saying that it should not be lost during the time of measurements. So if, let's say, you are going to measure it after 1 hour, okay, maybe after 1 hour it is evenly distributed. Within that 1 hour, it shouldn't either be metabolized or excreted, okay. So we are talking in terms of the time duration, okay. Good. So let's see. So let's look at this question so that we understand. So imagine a 70 kilogram man, okay, and we injected 150. Okay, no, before I come to this one, let's look at this. I was talking about this slide. So for the total body water, note that because water is everywhere, okay, if we use heavy water, okay, if we use heavy water, which is D2O and then T2, if you remember from chemistry, okay, these ones, heavy water. We call these ones heavy water. Okay, they are radioactive water. Okay, those ones can move everywhere. So when you see this water, just know that we can use these ones to, as well as antipyrine. We can use them to measure the total body water. Okay, and then we know the mixing time as 3 hours. So you have to wait for 3 hours. Forget about the mixing time. What you should remember is this part. Now, for extracellular compartment, usually what is used is inulin. You see, if you want to measure the extracellular compartment, the dye you are going to use should not be able to enter the cells. So if it can't enter the cells, it will stay within the plasma, and then it should stay within the how do you call it, the interstitium. Okay, so the commonest one we use is inulin. Okay, inulin, but you can also use mannitol and other things. But remember, usually what they ask about is inulin. Okay, good. Then how do we measure the plasma volume? Now, for the plasma volume, if you are using a dye that will only stay in the plasma, okay, that dye shouldn't be able to pass through the capillary space, because the capillary is the is the part that separates the plasma from the interstitium. Okay, so if you are using a dye that cannot pass through the interstitium, sorry, that cannot pass through the capillaries, then it will stay within the plasma. Okay, and usually what we use is albumin. We use albumin, and then we link it to iodine, which is radioactive. So we use radioactive albumin, as well as a certain dye we call Evans blue. Okay, so when you hear Evans blue, remember that we use it to measure the plasma volume. These are the most important ones. So you notice that we don't have any dye to measure the intracellular compartment directly. So what we do is that after we get the total body water and then the extracellular fluid, then we subtract to get the intracellular fluid. In the same way, there is no way of measuring the interstitium directly. Okay, so what we can do is that after we get the extracellular fluid, okay, we can subtract the plasma volume from it to get the interstitium. Okay, good. So now let's see this question. So they are saying that if there's a 70-kilogram man, okay, and he has about, we injected the person with 150 milligram of inulin. Okay, so now we know that inulin is used to measure the extracellular fluid. Okay, so in the estimation of extracellular fluid, we are going to use inulin. So after 24 hours, they took sample of the person's blood and analyzed and saw that the concentration is 0.1 milligram per milliliter. Okay, and then it was estimated that 10 milligram of it was lost. So as we said, ideally none should be lost within the time of mixing. That's the 24 hours.